Okay, so today what we are going to do is your tutorial 4 on binomial distribution and normal distribution. Any problems so far? Anyone managed to finish everything? Okay, so what is the problem? Very hard. Okay. Now, first thing you have to deal with binomial distribution. So what kind of, we always say, what kind of question will be asked for binomial distribution? What kind of question will you generally be asked for binomial distribution? That is all probability. Distribution is always about probability. But what kind of usual questions? So, okay, let me give you an example. So binomial distribution is to calculate a question that looks like this. Let's say you are given a test. Okay. This test is, for example, 24 choice MCQ. Okay. And let's say if the test question is in a language that you don't even know, all you can do is you can just guess the answer. Okay. Then the question is to ask you, what is the probability of X number correct? Okay. You can only guess the answer. You do not know anything about questions. 20 MCQ, what's the probability of getting something correct? Okay. This X can be what's the probability of getting 5 correct answers. So this is the kind of stuff that you use for binomial distribution. Okay, what this means that because you can only guess the answer, each question has 2 outcomes. Okay. Every question has only 2 outcomes. These 2 outcomes can be phrased in correct versus wrong, or in statistics term will be success versus failure. Okay. Once you have a trial that has only 2 outcomes, when something has only 2 outcomes, this is what we call as a Bernoulli's trial. A Bernoulli's trial is any test that has only 2 outcomes. All right. But the outcomes also mean this way. Let's say you have 4 choice MCQ, and you do not know, you can't even read the question. It's in a totally different language, for example. You can only guess. So what is the probability of getting correct? There's 4 choices. What's the probability of getting correct? You can only choose, randomly choose. How many percent you get it right for one question? 25%, correct. So which means that from here, because there are 4 choices, it means that the probability of success is 0.25. Okay. And therefore, 1 minus the probability of success gives you the probability of failure, which is then 0.75. Okay. This represents the probability of success. This represents the probability of failure, which is Q. So you add these two up, P plus Q always gives you 1 for a single question. So this is condition number 2. Okay. The first condition is it must have only right and wrong. The second condition is probability of success and probability of failure gives you 1. Okay. Either you can be correct or wrong. You cannot be halfway. The third criteria for using binomial distribution is that the probability of success for each Bernoulli's trial is the same. Okay. That means every question, the chance of getting right randomly is only 25% for every single of the 20 questions. Which then implies also the probability of failure for each question is also the same. Okay. So once you have these 3 conditions met, you can use your binomial distribution or your binomial theorem. Binomial theorem simply says that the probability of getting a correct answer, that means x equals to r. What's the probability of getting right? Is the total number, in this case 20, combination of r multiplied by the probability of success, the power of r, q, n minus r. Okay. That's all. So how do you do that eventually? So in this case, what is the probability of getting 5 correct? You then write out the probability of getting 5 correct. The total probability is 20 questions. And you want to get 5 correct. Now, P, you already have it here. This is P. So it's 0.25 the power of 5. Q is 0.75 or 1 minus Q. So it's 0.75. And you have 20 minus R, which is 5. On your fingers. Okay. That's how you calculate. Nothing very much. So can somebody take out a calculator and calculate and see what happens? Huh? 0.202. I have no idea. Assume you get it right. 0.202. Okay. Assume you press the calculator correct. So essentially, this means that you have 20.2% chance of getting 5 correct. Is it 0.202? Okay. So far so good. Now, which also means that if you were to add up every single probability, you add up the probability of getting 0 correct plus the probability of getting 1 correct all the way to the probability of getting full marks also equals to 1. Okay. So you can calculate that out yourself. What's the probability of getting 0 correct, probability of getting 1 correct, all the way to 20? So which means that based on this concept, you end up with a few different things. So you have a probability over x from 0 all the way to 20. Yes, 0 correct, you end up with very small chance. Okay. It will end up pretty much a curve. It's not, it's supposed to be more or less a symmetrical curve. It will look something like this. The area under the curve is then equals to 1. That is the total probability. Okay. So far, any problem here? So for example, I can ask you a different question. Let's say, what is the probability of at least 18 corrects? At least 18, so 18 is included. So you just take 18 plus 19 plus 20. So you repeat the same equation throughout. Okay. That is essentially binomial distribution. They'll just ask you one type of question. So far, so good? Yes. At least 5 correct. At least 5 correct, so you have 5, 6, 7, 8, 9, 10, all the way to 20, right? Of course. Then you just take 1 minus 0 correct, 1 correct, 2 correct, 3 correct, 4 correct. Depends on which one you want. Okay. So it's up to you. Which one is easier? Which one is less calculation? If at least 5 correct, you want to take 5 all the way to 20, fine with me as well. If you want to take 1 minus 0, 1, 2, 3, 4, also fine with me as well. Okay. Now, anyone did your A Maths in secondary school? Who did your A Maths? Raise your hand. You still remember your A Maths? Okay, so this is what happens. Now, the area under the curve is actually equals to 1, which also means that if my number of choices, my question, increases to a large number, 50, 100, 200 questions, this curve becomes a normal distribution. So I can use it to estimate the equation will have a function, your probability will have a function of x. Then if I want to calculate the area under it, let's say I want to calculate area between 12 and 15. From here, what you learn in calculus is you have to first integrate and you calculate from 12 to 15. Or the other way around, I can't remember. Doesn't matter. Okay. So you have to integrate it first. Okay. So which means that based on this criteria as well, how do you get the area under a curve equals to 1? The integral goes from 0 to n equals to 1. So what is the equation that gets you this condition? Which is why when binomial distribution, you have large number of sample size, it becomes normal distribution. But we will settle one at a time. So based on this, we can start to do your tutorial questions, the tutorial question 2. So how do you do your tutorial question 2? Let's settle this. Your tutorial question 2, 3, 4 is using binomial distribution. 5 and 6 is using a normal distribution. Later we talk about normal distribution. Okay. So question 2 tells you that in a large population, the proportion of short-sighted is 73%. Okay, so 73% short-sighted. Okay. You have a random 7%, 7 people chosen, so n equals to 7. Okay. What is the probability that all of them are short-sighted? So how do you do that? So the probability of short-sighted, which means that your P equals to 0.73. Okay. Your Q is then 1 minus 0.73. That gives you 0.27. You want all 7 people to be short-sighted. Then let's work it out. X equals to 7. Okay. Put it back into this equation. Okay. Which is actually 0.73 to the power of 7. Because this will equal to 1, this equals to 1. Okay. So you end up with about 11%. Yes. Can you use factorial? You can. But why kill yourself in the process? That is fine if you get the correct answer. If you get the wrong answer, nobody can save you. Okay. So question 2b. More than 5 are short-sighted. So you're asking probability of more than 5 short-sighted out of the total of 7. So is 5 included? More than 5 short-sighted is 5 included? No, so it's 6 and 7. Then you do for 6 and 7. Okay. So you repeat the whole equation as well. 0.73 to the power of 7, 0.27 to the power of 1, plus here 7, so it's equivalent to the same thing. 0.73 to the power of 7, 0.27 to the power of 0. To add up, this gets you to about 39.6%. Now, question C. 3 samples of 7 are taken. So total, what's the number now? 21. Okay. So n equals to 21. Okay. Comes from 3 samples of 7. Then you want to find 10 people who are short-sighted. Okay. What is the probability that 10 are short-sighted? The n has to change from 7 to 21. The probability remains the same. 0.27, and here will be 11 because it is 21 minus 10. So you end up with 0.843. Okay. Now with this, can you do question 3 and 4? The first part of question 3 and 4. So for part D, let's do question 2, part D first. What you want is assuming that the population is normally distributed, your sample size is very large. Remember, when sample size is very large, it becomes a normal distribution. Okay. So you assume that X is approximated by 73, 73 and 19.7. Okay. Yep. So how do you do this in the first place? What is the probability? Find the probability of 99% having one chance of getting a short-sighted. One or more short-sighted. How do you do that? What is the other question? So the question is, what sample size you must have to find out essentially one short-sighted person. And the probability that they want is 0.9 times. So how do you do that in the first place? You need at least one short-sighted. So what is sample size you need? Basically, you're asking, what is this number n that you need? Okay. So in order to write it out, at least one short-sighted can be 2, 3, 4, 5, 6, 7, 8, 9, or so on, right? So when you write it out, at least one short-sighted, you're taking this, the probability of x more than or equals to 1. And you equate this to more than 99% or equal to 99%. Which means that the probability of 0 is less than 1%. You invert it opposite way. The probability of x equals to 0 has to be less than or equals to 1%. You're doing the opposite. It makes sense? How many of you do get this part first? You want at least one person to be more than 99%, which means that the probability of getting 0, everyone is not short-sighted, is actually less than 1%. So if you draw it out in a graph format, you do not know what is the number here, what's the maximum number. All you need to know is there is a number that in order to get 0, this is 0 here, okay, this is 1, and so on. You do not know what is this final number here, and that's what you want to find out. But all you know is this area, this block that is shaded, is less than or equals to 1%. The rest is more than or equals to 99%. So once you have it, it makes your life a lot easier already. You just put in the binomial equation. Okay. So you have n. Okay, the probability is still the same, 0.73. Okay. And then you have r. That is 0.27 and minus r is less than or equals to 0.01. So all you know is this fits into the equation. Okay. N minus 0 is still n. Okay. Here is 0. This is 0. Okay. Now, the only thing that you do not know is what on earth is this number here. Right? Now, why not you just try? What is 50 C0? Just press on a calculator and see what happens. 1, right? Let's try 40, 0, also 1. So you are actually asking how many ways from a bin of 50 you choose nothing. There's only one way of choosing nothing. You're actually choosing nothing. It doesn't care how big or how small the bin is. So this is 1. It doesn't make any difference now. Which means that all you care is this part. 0.73 to the power of 0, 0.27 to the power of n is less than or equal to 0.01. What is something to the power of 0? Also 1. This is also 1. So you have 2 of them is 1 already. which means all you have to care is this part. Okay. Now, how do you bring the power down? What mathematical operation can bring the power down? Some form of log. Either you use log or log, it doesn't matter. So you can use your okay. Then you bring it over. So you end up with about 3.52. So you cannot have 3.5%. So minimum number you need at least 4 persons. Okay. So the easiest way, if you look at it, 0.27 to the power of 4 is what? What is 0.27 to the power of 4? Calculator, 0.27 to the power of 4. Huh? 0.005. Okay, doesn't matter. 0.27 to the power of 3. Correct. So this number is actually in between here. Because that is the only one that matters at the end of the day. Okay. So you are talking about 0. The whole equation ends up just this part here. You're finding out what is n so that the answer is just less than 0.01. You can work out 0.27 to the power of 1 to the power of 3 to the power of 4 and so on. If you want to do that, also possible. Check. So if I have a sample size of 3, the chances of getting one short-sighted is actually it's actually nearly 2%. It's not 1%, not less or less than 1%. So you need at least 4 to be less than 1%. You can't get exactly 1%. Exactly 1% means 3.52%. So far, so good? Yes. You divide, the sign will change. Yeah. Okay. So you can do part A, part B, part C, part D already. How about part E? Okay. So part E tells you that when the sample size is large, it follows a normal distribution where n is 73, 19.7. So 73, what is 73? Is it the mean, standard deviation, or variance? Which one? What is 73? Is it the mean? Huh? The mean, correct. So this is the mean. How about 19.7? Is it standard deviation or variance? Check your notes. Is it standard deviation or variance? Is that S or S squared? S squared, correct. So this is actually your variance. Right? So you want to find the probability. Let's say you have a sample size that's large. You want to find the probability that X is more than 80. Okay, this is where you have to learn about your normal distribution now. So let's go to your normal distribution. So your normal distribution actually have a standard, it's a standard formula. This is your probability as well. The mean of the normal distribution, this is your z-axis. Okay. The mean of it is actually 0. The standard deviation, that is by standard deviation. So this is 1, 2, 3, and so on. -1, -2, -3 standard deviation. Okay. Now, if you want to do statistics well, you have to learn normal distribution very well. That is a very fundamental basis. Okay. Without your normal distribution, nothing works. Okay. So what are some of the properties of normal distribution? Number one is it is symmetrical. Symmetrical about the mean itself. That means the area on the left-hand side and the area on the right-hand side is the same. Okay. That's why your table only gives half the curve. It doesn't give you the opposite half. Because it's symmetrical, it means that the probability of, let's say, z more than a certain value, let's say more than 0.7 is actually the same as the probability of z that is less than minus 0.7. The second thing that we know is the same thing, the area under the curve. Before we talk about area under the curve, the second property is, we haven't learned this term yet, it's called asymptotic, which means that the line never touches the horizontal axis. Asymptotic. The line never touches the horizontal axis, which means that z can go negative infinity to positive infinity. From this criteria, you end up with the third property. You want to find the total area under a curve, you have to integrate from negative infinity to positive infinity. That's the total area under the curve equals to 1. So there is a formula for this curve. Yes. Now, any problems so far? From here, from the third step, we actually have a fourth property. It's actually pretty useful and pretty unique. When you talk about normal distribution, you no longer care whether is it more than or more than and equals to. It doesn't matter at all. There is no difference. Nothing. That doesn't matter. Because why? What is the probability of z equals to a certain value? Let's say of z equals to 1.25. Can anybody guess? Sadly, no matter how much you hate maths or what, this is all the maths you need. What do you think is the answer if you go from step 3 for those who have done integration before? Answer? Make a guess. When I usually ask you to make a guess or something like this, you have a very definite answer. Who wants to try? 1. No. 0. It's not 1. Because it's 1 here already. That'll be once. And do you know why is it equals to 0? Think about this. Equals, right? If you actually put it into here, what if you integrate it? What is 1.25 integrate to 1.25? It doesn't matter what function it is, it's equals to 0. Because it minus itself off. This actually becomes 1.25 minus 1.25. It becomes 0. It is as good as saying 1.25 is here. What is the area of this line? The area of this line is 0. So what is the definition of a line? Anybody know what's the definition of a line in maths? That's the original definition. A line is a breathless length. Just a length without breath. If the breadth is 0, doesn't matter what's the length, it will be 0. The area will be 0. But very often we do not bother with this part first. Instead, our data tends to come up as a value. So we can draw another value that is your x-axis. If this is your x-axis, z equals to 0 is actually your mean, equivalent to a mean. Okay. And then you have different values here. So for example, we take this x value as your IQ score, for example. Okay. What is the average IQ score of a person or population? Anybody knows? What do you think is your average IQ score? If I do IQ test for 1,000, 2,000, 3,000 people. It's 105. Okay. Generally, IQ test, the average is 100. Okay. Because what is IQ? Anybody knows? Intelligent quotient. So IQ is basically your mental age divided by your chronological age. Chronological age. So it means that if you are 5 years old, you have the mental ability of a 6 years old. Then you're 5 years old, your mental ability of 6 years old, your IQ is 125. That's basically what it means. Okay. This is for development when you're a child. Now you are 18 years old, it doesn't make any sense you have a mental development of 20 years old or not. The standard deviation of IQ score is about 15, 14 point something, about 15. So which means that this value here is 115, 130, 145. Do the opposite, here will be 85, 70, and 55. Okay. Now, because it's asymptotic, it doesn't touch the x-axis. Is there a minimum IQ score? Technically, is there a minimum IQ score? Is it possible to have a minimum IQ score? Statistically, not possible because it doesn't touch x-axis. It can go to negative, but it doesn't make any sense at all. But there is a practical limit. It can go to 0. Okay. Now, hopefully none of your IQ is 0. If you will not be here anyway if you're 0. Can you do? How many of you keep pets at home? Anyone keep some form of pets? What pets do you keep? Huh? Cockroach? Okay. Can you administer your IQ test on cockroach? Possible. You just read out the IQ test and then you decide that if the cockroach run to the left, it is 1, the cockroach run to the right is 2, or whatever thing, up to you to decide. So you read it out and then see whether the cockroach run or not. And decide if the cockroach doesn't run, then it's scoring nothing. Then give out on the question. Remember, when you give out the question for binomial distribution, all the wrong answers, x equals to 0, still have a probability. Right? So it hits 0 as well. Okay. There is, if you go to the actual IQ chart, there is an IQ, the lowest IQ is 0.03. That's the IQ of the table. That means you read every question, it doesn't answer. That is here. Probability of x equals to 0. Get every single answer wrong or no answer at all. Is 0.03. Okay. Similarly, there's no highest IQ as well. So how do we convert between these two axes? Between the x and the z axis? Huh? Yeah, between the z score and the x axis. What's the formula for it? The z score is essentially any value you want on the x axis minus of the average divided by the standard deviation. So how do you get from 115 to 1? It is actually 115 minus the mean, which is 100, divided by standard deviation of 15. So you get 1. So either way around. Now your probability, your normal distribution table actually tells you how to calculate, how to read off. So if you look at that, it only gives you the right-hand side. So for example, if you go to 3, that equals 3.0. Okay. So you go to 3.0, you go to a column here, the row 3.0, then the first row is 3.00. Then the next one is 3.01, 3.02, and so on. So the area here tells you that 3.0 is 0.0013. Okay. Which means this part is also 0.0013. Okay. So there are two ways of using this table. One is you use the area, you find the area is in the center. You find out what is the z-axis, the z-score. Or you have the z-score, you find out what is the area under the curve. The right side, what's the area under the curve. So you have to think about how to actually play around with these scores. So here what we have is 80. Basically, you do everything else, you reverse all the numbers. And you say that this is 80. This is 73. 19.7 is your variance, so you square root it first. What is 17.9 square root? Square root of 17.9. What? 4.44. Okay. So which means 17.3 plus 4.44 is what? 73 plus 4.44. 77.44. 77.44 plus 4.44. 1.88. Okay, that's all we need. Now, what we have is more than 80. So 80 is somewhere here. This is 80. So you have to calculate what is the equivalent of the z-score. So you have 80 minus 73 divided by the square root of 19.7. Then you calculate what is this z value. End up with 1.58. So here, this value here is 1.58. So then what you are looking at, what is the area up here? So you go to a table, find z equals to 1.58. 1.58 gives you 0.571. Okay, that's it. Okay. So then the next question asks you for what is the probability of 70 to 80? Okay, so now you have. Next, we do the reverse. Let's do the reverse first. If you think about this, what is 73 minus 1.4? 73 minus 4.44. That's 73 minus 1. 73 minus 4.44. 68 point what? Use a calculator, don't need to use a hand. Huh? 68 divided 6. 68. 56. Okay. So you want from 70 to 80. 80 we already know already. So we want from 70, which is somewhere here. This value is 70. So we calculate what is the equivalent of this value here. All right. This part, we get so you take 70 minus 73 divide by square root of 19.7. What do you get? Negative 0.68. Correct. So since the negative value is not on the table, how are you going to read it? Negative value is not on the table. So we use here the probability of that negative minus 0.68 is actually equivalent to the probability of that is more than 0.68. Okay, so you can actually read the opposite side. You flip the whole thing on the opposite side and see how it looks like. So now this part, you take 1.68, and this is 0.2483. So indirectly, what you're trying to figure out is this question here is asking you what is the red shaded area. So how do you find it? The red shaded area, you know the total area is what? So you have 1 minus this minus of the probability of x that is more than 80. Then you have 1 minus 0.2483 minus of the what you already have 0.0571. That gets you 0.96946. So this is the area here is 0.6946. Okay, any problems so far? Okay, who can do question 2 or question 3 already? Let's try. Okay, so what I'm trying to say is For probability, if you do not know which part of the curve you are looking at, draw it out and see. Otherwise, you probably get the wrong answer. So question 3. The SME is hiring. Let's try this. And there are 2 rounds of interview. Okay. So first round, you have 10 interviewers. So n equals to 10 interviewers. The probability of passing a candidate. Everyone passing a candidate, the probability of passing a candidate is 90%. Very relaxed. Which means that the probability of failing the candidate is only 1%. Okay. But the candidate fails if more than 1 interviewer decide to fail him. So if more than 1 fail equals to failed. So what is the probability of getting through the second round? More than 1 fail, then you fail. That means you need to have at least 2 failures. Two interviewers say that you cannot pass. So what is the probability of going to round 2? How many interviewers have to pass you? Only one, at most only 1 can fail. So if 8 interviewers pass you, can you still go to round 2? Yes, no? If 8 interviewer pass you means that 2 interviewer fails you. You cannot go already. So you at most only 1 failure. So you're looking at 9 interviewer passing you or all interviewers passing you. Okay, then you work out the same equation. You have 10, 0.9, the power of 9, 0.1 to the power of 1, plus 10, 0.9 to the power of 10, 0.1 to the power of 0. So you end up with 73.6% or 0.736. Okay. Okay. So now you go to round 2. Second round. What happened in second round? There are only 3 interviewers, which means that n equals to 3. The probability of passing is only 80% now. Probability of failure is 20%. But for the second round, you need all 3 to pass you. So which means to pass your second round of interview is equivalent to all 3 have to pass you. All right. what is the probability of getting a job? The probability of getting the job, first you have to survive the first round, going to round 2. So probability of pass first round plus the probability of passing the second round. Not plus, multiply. So the probability of passing the first round is really known here, 0.736. The probability of passing the second round is what you need to calculate using here. So it's 3, 0.8 to the power of 3. Then you end up with so you end up with 37.7%. And that's what you're trying to show. Getting a job for potential candidate is 37.7%. After which you do the reverse, you're asking how many people I need to interview before at least 98% get the job. At least I have a person that can offer the job at the end of the day. How many people I need to interview? Okay. So to do that is using the same equation as what we did before. You start off with a certain number. Okay. And you want a total of at least 98% that you have a job offering. How many people do you need here? To reverse it, you just need to find no offering at all. To get no offering, then you do the reverse. Is 2% of a chance. So no job offering is 2% of a chance. Then you work it out. Your probability here, 0.377 of no job offering. Then you take 1 minus 0.377 of n. Okay, so this is less than 0.02. Similarly, this equals to 1, this equals to 1. So the only thing is you have 1 minus 0.377, the power of n equals to, or is less than or equals to 0.02. So using your log, end up with, you need to have more than or equals to 8.267. So minimum number need to interview 9 people. Yes. Yeah, so you have this already.
How do you make? How come the end at the end is like more than how
You use log to actually bring it down. The logarithm to bring down the power. That's the only way you
As
can do it.
in, yeah, you use not already.
Yeah.
Then it's still less than or equal.
You flip the sign because we have to divide.
Like, as in, what about dividing again?
After you change here, when you divide, you have to change the sign as well. Huh? It's just exactly what we did just now. So you end up with 1 minus 0.377 the power of n 0.02. Okay, if you cannot handle more than or less than, then don't bother with more than or less than. Later, see which one makes more sense. They can treat it as equal. So you end up with this. When you do the division, originally, this is more than, you have to change the sign here. This way, you have to change the sign. Okay, it's only this step. But yeah, it doesn't matter. Log alone doesn't matter. You still get the same answer. Okay, so question 4. Who want to come and do question 4? I'm sick of doing already. Anyone have done question 4? Okay, so why not I give you about 5 minutes, do question 4 yourself. And after that, Matthew come and do question 4. Before I show you how to do question 5, and then somebody come and do question 6. Who have I not caught so far? Who have I not caught to do questions before? So Matthew, later you come and do question 4. Okay, then you do question 4. Okay, then question 6. Which lady want to do? Let him do it. You want to do question 6? Why? Okay, wait, Marcus. Question 4. Okay, so you'll be for the next week already. Okay. So Sneha, you do question 6, okay? What? Last week you have. So who have I not caught so far? Any remember? I can't remember who have I not caught. I know I caught Serena already. I know I caught Rina already. Dana, have I caught? Yeah, okay. Who have I not caught? Okay, so last week, help me keep track who have I not caught. So you go and, yeah, I know. So you can arrow somebody, one of your lady friends, go and put it. Yeah, okay, you. I don't know. Just look at the phone and see who comes up. Huh? You want to do? What? 1 minus no candidate. One candidate. how many people want at least one candidate? At least one candidate, right? Means that you only minus off the chances of no candidate. So it's that out of 20 MCQ, what is the chances of getting at least one right? You need to minus off the chance of no rights. So what is the number A here? How many candidates must you give it to? So that at the end of the day, 98% of the chance at least one. Okay. So which means that the chances of not getting a candidate at all is 2% of chance, right? No candidate at all. So you pick 1 minus this, this is really zero. So there's no 1 minus this. Yeah. Less than 2% chance, more than 90%. The other one, okay, good. Yes, marvelous. Try physics. Okay, those who are doing question 5, your 5C, if you get 53 and $53.3, then you get it right. 5A is 0.159, 5B is 0.309. To get that, you're close enough already.
I see like what C on them.
But see,
I think all here.
oh, here. Get it right here, right here. But see, you have to use the part B answer.
Okay, mine is a bit more than 0.34.
Okay, close enough.
But my working name here.
Question 5. Question 5. 5A is 0.159.
Let me read a question.
So this is correct. So it is 0.311. It's correct. It's about 0.8. That is correct. So it's 1 minus. It's one. It's just 1 minus this one.
I don't know. Wait.
It's just 1 minus this. 1 minus more than 1.
Wait, what's the question? At
One
least,
box and 5 to 8.
at least one box.
So it's 1 box 5 to 8. So you only have 1 mark. At least is 1 box with 5 x is equals to 1 minus box with 0 per cake.
1 minus. At least 5 again.
This is probably a 5 cake. Right. So then, think already. You have 10 boxes. This is actually 0. And 0. Then here, this is where you got 0 point.
Oh, yeah.
6, 4, 0, 5 by 1 minus 0 0.046.
Wait, that's what I did. I just found it.
Yeah, we get right. Yeah. Yes. What? Which one? Yeah. Okay. So question 6. Where is my question 6? Question 6. Huh? 5 what? 5B. Where's my 5B? 4. Which 4? Which 5? Which 5? 5B is 0.309. Of 16 months. Correct. Beautiful. Yes. So 26 correct. Which one? 5A. 5A is 0.159. Okay. So yes, that's how all the maths that you need to clear. Yes, what? You have to think about how you do it. Which side, because it's not always 1 minus something. So which side is easier? Sometimes, okay, so let's say if you have 50 MCQ, okay, so what is the chance, what's the probability of getting 45 marks and above? Or less than 45 marks? You can take 1 minus 46, 47, 48, 49, 50, or you want to do from 0 marks to 35. So you think about it, which one is easier? That's why you draw the curve. Which side are you looking at? Which side are you interested and which side is easier to calculate? Okay, so that's all for today. This will be included in your test for sure. It's part of the test. Okay, so 2 weeks from now is your term test already. Your term test timetable is out as well. So when is BDA term test? I still do not know. Thursday? Wednesday. Okay, very good. Did all of you survive? Five part B, 0.309. Okay.